In this next video, we will talk about linear inequalities that we can use to solve different types of real-world problems. It is important to note that there are key phrases that denote an inequality. X is less than A is the inequality X is less than A. X is greater than A is the inequality X is greater than A. X is at most A is represented by X is less than or equal to A. X is at least A is represented by X is greater than or equal to A. X is no more than A means X is less than or equal to A. X is no less than A means X is greater than or equal to A. And X is more than A is simply X is greater than A. Let's look at an example. Air temperature decreases as elevation increases. Suppose the temperature at the base of a mountain is 32 degrees Fahrenheit. The temperature X feet above the base of the mountain is given by T equals 32 minus 0.0054X. How many feet above the base of the mountain will the temperature be less than 10 degrees Fahrenheit? To solve this problem, we want the temperature to be less than 10 degrees. So that is, we want T to be less than 10. We replace T with its equivalent expression, which is 32 minus 0.0054X is less than 10. To solve for X, we want to subtract 32 from each side to get negative 0.0054X. It's less than negative 22. Now we divide by negative 0.0054. Remembering that dividing by a negative sign will reverse the inequality symbol. Therefore, we get that X is greater than 4074.074. Therefore, the temperature is less than 10 degrees Fahrenheit and elevations of more than 4,074 feet. Example B is that Jada has $30 in store bucks and a 25% discount coupon for a local department store. How much can she purchase so that after her store bucks and discount are applied, her total is no more than $100 before sales tax? And we want to understand that the $30 store bucks are applied before the 25% discount is applied. So we have really two things going on. First, we need to know that X is our purchase price. When we apply the store bucks, we decrease that amount by $30. Therefore, X minus 30 is the remaining price after the store bucks. Then we get a 25% discount applied, but when we have a 25% discount, that means that we only have to pay 75% of the price. So this means that we're paying really 75% or 0.75 times X minus 30 is the 25% discounted price. And then we want this to be no more than $100 before sales tax. So therefore we can solve an inequality that is set up by 0.75 times x minus 30. To be no more than means it's less than or equal to 100. If we distribute on the left, we get 0.75x minus 22.5 is less than or equal to 100. So we can add 22.5 to each side to get 0.75x is less than or equal to 122.5. And lastly, dividing by 0.75, we get that x is less than or equal to 163.33. So this means that Jada can actually purchase $163 worth of merchandise, but pay no more than $100 before sales tax. Now the last two examples are going to refer to averaging grades. To earn a B in an algebra course, a student must have a test average of at least an 80. Charlie has grades of 83, 72, and 79. What score does Charlie need to make on his fourth test to earn at least a B in his algebra course? So that is, we want his average of the 4 tests to be at least a B, which means greater than or equal to 80. Would you remember, to compute the average, we have to add up all of the scores and divide by the number of scores. What do we not know? We don't know his 4th test, so we're going to let x represent his 4th test score. So we will add up 83 plus 72 plus 79 plus our 4th test, x. All of that's divided by 4 and has to be greater than or equal to 80. So adding the numerator, it really is 234 plus x divided by 4 is greater than or equal to 80. Now we can multiply each side by 4 to clear fractions. And we get 234 plus x is greater than or equal to 320. So we can subtract 234 from each side. To get x is greater than or equal to 86. So that means that Charlie needs to score an 86 or higher on his 4th test to have an 80 or higher average on those 4 tests. The last example is dealing with a weighted average. The final grade in an algebra course is based on a weighted average. Homework counts 15%, quizzes count 10%, tests count 50%, and the final exam counts 25%. Tyrus has a homework average of 73, a quiz average of 79, and a test average of 65. What score does Tyrus need on the final to have at least a 70 for his final course grade? So that is, we want the weighted average to be at least a 70, which means greater than or equal to 70. Well, the weighted average means that we're going to multiply the percent times the average for each of those categories and add them up. Homework is 0.15 times his homework average, which is 73, plus quizzes are 10%, so 0.10 times a quiz average is 79, plus tests are 50%, so 0.50 times the test average, which is 65, plus the final exam, which is 0.25 but we don't know that score yet, so it will be X, and that's greater than or equal to 70. So if we use our calculator and add up all of these terms on the left, we will get 51.35 plus 0.25x is greater than or equal to 70. We subtract 51.35 from each side to get 0.25x is greater than or equal to 18.65. And then we can divide each side by 0.25 to get that x is greater than or equal to 74.6. So that means that Tyrus would need to score at least a 74.6 on the final to have at least a 70 course grade.